So we're going to worry about what we call difference of squares, or how we're going to factor and expand. So some of this stuff's not going to be earth-shattering to you. It just might be a little bit different. But if we look at perfect squares, so perfect squares are something that literally it's just to the power of 2. So 1 to the power of 2 is 1. 2 to the power of 2 is 4. 3 to the power of 2 is 9. So again, remember, it's just the number times itself, right? That's all that is. So 4 times 4, 16, 5, 25, 36, 49, 64, 81, 100, 121, 144. So these are some things that you guys have probably dealt with for a little while now. But you're going to see how these are relevant shortly, okay? So remember, factored form has 2 brackets, or when we did greatest common factoring, it had a number and then a bracket. So that sort of stuff is continuing. Now, if we look at square roots, it's just the square root or the opposite of what we just did to the perfect square, right? So square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. And so on and so forth. 4, 5, 6. Square root of 49 is 7. 64 is 8. 81 is 9. 100 is 10. 121 is 11. And 144 being 12. Okay, so we have perfect squares are squaring a number, and the opposite of it is the square root. So when we look at the difference of squares, so you'll see that it's kind of like x plus a number, x minus a number. We're going to find a difference of squares when expanding. So x minus bracket x minus 3, bracket x plus 3. Well, once we expand it, if we did our FOIL, so first times first would be x times x being x squared. Negative 3x times x is negative 3x. 3 times x is 3x. And then negative 3 times 3 is negative 9. And if we broke that down, you'd notice that for a difference of squares, these middle numbers cancel themselves out. So we'd just be left with x squared minus 9. So we wouldn't have that b or that d that we usually have in what we looked at before. So if we looked at x squared plus bx plus c, this middle number is basically taken out of the scenario. If we look at the example beside it, we have x minus 5, x plus 5. Well, x times x being x squared, x times 5 being 5x, negative 5 times x being negative 5x, and negative 5 times 5 being negative 25, where these numbers cancel themselves out. 5x minus 5x, well, it is 0. So you'd be left with x squared minus 25. So we're going to show you what it looks like. We're going to expand it and show you, but if we just did our FOIL again, our firsts, our outsides, our insides, and our last. So the first being x times x, our outsides being x times 3, our insides being negative 3 times x, and then negative 3 times 3. So we'd be left with x squared, and then 3x minus 3x would cancel each other out, and then we'd be left with negative 9. Okay. If we showed you, if I just didn't write that all out and just solved it kind of as is, it'd be x squared, and then x times 5 would be 5x. Then negative 5x, or negative 5 times 5, or negative 5 times x would be negative 5x. And then negative 5 times 5 being negative 25. Once again, these cancel each other out. X squared minus 25. Okay. Now we're going to have a slightly different example, but firsts, outsides, insides, lasts are still going to apply. So 2x times 2x is 4x squared. 2x times negative 3y would be negative 6xy. 3y times 2x, both positive, being positive 6xy. And then 3y multiplied by negative 3y would be negative 9y squared. And if we look at this again, those would cancel out. 4x squared minus 9y squared. So if we're in a situation where we have x minus a number, x plus a number, and these two numbers are the same, our result is we're going to have to cancel out the middle term, okay, which is what we did. So take a second there to write that all down, and we'll move on. All right. So now we're going to look at factoring a difference of squares. So when we're given the opposite, so when we're giving it expanded, what's it going to look like, okay? So it says a difference of squares can always be factored in the following way. So x squared minus y squared equals x minus y, x plus y. So you're going to simply identify whether you have a difference of squares. So if you see it is a number, or sorry, a letter, so say x squared minus a number, that's typically going to be your difference of squares if this number can be square rooted into something whole, okay? So examples like we did at the top, so 144 or 25 or 9 or 49 can all be square rooted to a whole number. So you're going to create two sets of brackets, take the square root of the first term and place it as the first term in each set of brackets, and put an additional sign in one of the brackets and subtraction sign in the other. Calculate the square root of the second term and place it as the second term in the brackets. So that's talking about we're going to square both this number and this number, okay? So if we look at the first one, it's really easy when we just have something like this because it's a 1 and it's the square root of 1. Therefore, it would always just be x or 1. So in this case, we're going to set up our two sets of brackets, and x squared, the square root of x squared is just x. And then the square root of 9 or negative 9 is going to be 3, right? So in this, or the square root of 9 is just 3. Apologize. So in this case, it's just going to be x plus 3, x minus 3. Okay, pretty simple, straightforward. Now, if we do the next one, we're going to square both this and square both that. So it'd be y squared. The square root of that would just be y. And the square root of 25 would be 5. And we know it's going to take the shape of x plus 5, x minus 5. Okay? Does someone think they can help me with the next one there? No? Okay, so again, we've got m squared minus 81. So we take m squared, and we're going to do the square root of it, which would be m times m being m squared. And then we're going to do the square root of 81. And the square root of 81 is 9. 9 times 9. So we're going to have m plus 9, m minus 9. Okay. Now the last one's a little bit trickier, but it's really not that bad. We're going to square both of those numbers. And again, this only works when we have two numbers that we can square. We know we can square 4, and we know we can square 49. So it would be the square root of 4y squared. So the square root of 4 is 2, and the square root of y squared is y. And then we'll do the square root of 49. And the square root of 49 is 7. 7 times 7. So we get 2y plus 7, 2y minus 7. And that would be how we're going to do a difference of squares. Okay, so we factored based on the difference of squares. Remember, you need to have two things that you can square. And in this case, all 4 examples we can. So pretty straightforward, nothing too crazy, but super